This was our notes on two-dimensional figures. You were asked to model and find the measures, talking about area and perimeter, of two-dimensional objects. We were primarily concerned with parallelograms. Their examples are rectangles and squares. We're concerned with circles, and we're concerned with triangles. Starting with area, the area of a rectangle, or the area of a square, or the area of any parallelogram in general, is the base of the parallelogram times the height. If I wanted to know the area of this particular box, if I wanted to know the area of this particular box right here, I'd have to figure out how tall the box is, the height, and I'd have to figure out how long the box is, its base, and I'd have to multiply those two numbers to get the area of that box. For a triangle, skipping circles for a second, for a triangle, area is just half of the base times the height. If we just imagine our rectangle to begin with, and if we cut it in half, we get a triangle. That triangle's area would be half of the original rectangle. Then for a circle, it has a special formula for the area. It is pi times the radius squared. Your circle's radius, to be clear, just as a reminder, is the distance from the center to the edge. That distance is r. The distance all the way across the center, through the center of the circle, is called the diameter, d, diameter. Your perimeter is just the distance around a shape. The distance around a shape. You've heard of perimeter fencing. It's the fencing that goes around your house or around your school. To find the perimeter of a rectangle or a square or a parallelogram, or pretty much any polygon, you're just going to add all the side lengths. There are some special formulas at times, but you can generally just add up all the side lengths. So you'd find out what the base length is, and you'd have that on top and bottom. You'd find out what the side length is, what the height of the shape is, and you'd add up all these sides. You'd add up the orange and the orange and the blue all together. Same thing for triangles. You're just going to have to add up all the side lengths. For circles, circles have a fancy word for a perimeter. Their fancy word is circumference. And it has two different formulas. It is 2 times pi times the radius of your circle, the distance from the center to the edge, or it's pi times the diameter, the distance across the center of the circle. Either formula works. It's just whether you already know the radius or the diameter affects it. If you're going to find horizontal or vertical distances on a coordinate plane, either heading straight up and down or straight left and right, you could just subtract the coordinate values, or you could use distance formula. If you're going to find any diagonal distances ever, if you're ever going to find the distance between this corner here and this corner here, on a coordinate plane, you're going to use either Pythagorean theorem by creating a right triangle, or you're going to use the distance formula on the coordinates themselves. This is d equals the square root of parentheses x2 minus x1, close parentheses, squared, plus parentheses y2 minus y1, close the parentheses, squared. we're going to take a look at quick estimates for the area and perimeter of a heart. We're going to find an estimate for the area and perimeter of this heart. To do so, we're going to break this heart up into a couple of pieces to make it easier. We're going to imagine that the heart's point comes down to this coordinate as at 1.5 for a height, and is otherwise straight across, creating two hemispheres. Semicircles, creating two semicircles. We're going to focus on the area over here. If I have two semicircles just equals one circle. So we're going to have to find the area of one circle here, and to do so we're going to worry about the radius of the circle. Well, we can start with the diameter. From here to the center, it's a length of 3. So we can say the diameter is 3, meaning the radius is 1.5. Your radius is half of the diameter. The area of the circle then, using our formula pi r squared, is going to be pi times 1.5 squared. If you run 1.5 times 1.5 times pi in your calculator, you'll get an approximate value. Your answer is about 7. We'll leave our answer as about 7. And then the rest of the shape for this that we have to be concerned about is the top. We just found the area of the orange so far by using the fact that it's basically making a circle. 2 semicircles or 1 circle. Last thing we're going to worry about is the area of the bottom of the shape. The bottom of the shape is just a triangle. So focusing on the triangle, the area of a triangle is 1/2 the base of the triangle times the height of the triangle. Well, from one side to the other, I'm just going to use any flat side to be the base. It's easiest if any flat side, either perfectly horizontal or perfectly vertical, is the base. Looks like the base is 6, going from -3 to 3. I can count how far apart they are. I can say 3 minus -3 is 6. And then I can look at the height. The height will always be at a right angle to your base. The height appears to be 1, 2, 3 and a half, 3.5. So 1/2 times 6 times 3.5. If you run that, you get 10.5. So the total area for the entire heart, or our estimate for the entire heart, would be 7 plus 10.5. We're saying it's an estimate of 17.5 units squared. The perimeter, really quickly, of the heart If we're saying we have one circle, I just need the area, I need the perimeter of that circle, I need the circumference. So for the circle, our circumference is 2 times pi times the radius, which looks like 2 times pi times 1.5. That would be 3 pi, or in a calculator, 3 times pi is 9.4 when I round it. 9.4 units, since we're measuring a distance. The triangle has only 2 sides we need to worry about. We don't need to find this side length here. We need to find this side, this diagonal side length, and this diagonal side length. To do so, you could do, since it's a diagonal side, we could use Pythagorean theorem. That's what we can do. We see we've got a right angle here, we've got a length of 3. We've got a diagonal side, which has a length of 3 and a height of 3.5. We're going to use those in your Pythagorean theorem. A squared plus b squared equals c squared. 3 squared plus 3.5 squared equals c squared. You'll get 9 plus 12 and a quarter. You'll get 21.25 equals c squared. As an estimate, we'll get c is 4.6, roughly. C is about 4.6 when we square root it. Notice we have that side twice. You've got that diagonal side times 2. Meaning the red there is actually 9.2. We can add 9.2 and 9.4 to get a perimeter equals 18.6 units. One last thing, some classes got to go over it, some classes didn't. We have this coordinate grid, we see an equilateral triangle, and it's inside of this square. We're going to first off find the area of this square. To find the area of the square, let's just go from one point to the next. Let's find how long that is. You can count it, but that's a waste of time. How far is it from -2 over to 2? They're on the same height, so just how far is it from -2 to 2? That distance is 4. Since it's a square, I'm going to have that side twice. This side will be 4 as well. The area is the base times the height. It's 4 times 4. It's 16 units squared. Next thing to do is focus on the area of this triangle. Well, we see its base. It goes from a -1 to a 1. Always choose a base that's either perfectly horizontal or perfectly vertical. It saves you so much time. We're going from -1 to 1. That looks like the base is 2. And its height is going from that base straight up. Going from a height of 0 to a height of a square root of 3. So its formula for the area for a triangle is 1/2 times the base times the height. It looks like we're going to be doing 1/2 times 2 times the square root of 3. That's just going to be the square root of 3 altogether, units. And I'll leave this here currently, units squared. We'll leave the square root of 3 as it is. We won't turn it into a decimal. Then we're asked for the area of the square that is not covered by the triangle. Meaning, take your square's area and just take away the triangle. We're going to write an exact value, and then an answer rounded to the nearest tenth. We know the area of the square. We know the area of the triangle. The exact answer is just going to be taking away the triangle from the square. We're going to be looking to just find this area that is highlighted without the triangle. We're going to find this area without the triangle. It's going to be 16 minus the square root of 3 units squared. Your rounded answer is you're just going to type into your calculator 16 minus the square root of 3. 16 minus square root of 3 gives you an answer when rounded to the nearest tenth of 14.3 units squared.